Hey everyone, and welcome to today's Explainer. If you're a programming student just starting out, I want us to totally shift our perspective today. I want you to look at a broken code base not as some massive personal failure, but as a crime scene. And in this scenario, you aren't just a coder anymore. You are the lead detective. Your job is to analyze the clues, follow the logic, and crack the case. So today, we are going to master the art of the code mystery.
We've all been there, right? You write a program, it looks completely correct. The logic feels absolutely perfect in your head, but the second you hit execute, it crashes, or just gives you some wildly wrong output. Listen, if this happens to you, take a deep breath. You are absolutely not alone. Literally every single programmer deals with this. Even the elite pros working at Google, Microsoft, and Meta spend a huge chunk of their day just tracking down and fixing errors. It's totally normal. Okay, let's dive into this by laying down the official definition. Debugging is the structured process of identifying, analyzing, and fixing errors, or bugs, in a computer program. And honestly, what you quickly realize as you learn to code is that writing the initial script, that's really only half the job. The other, and honestly probably the more important half, is understanding exactly why the code isn't working and figuring out how to fix it without bringing the rest of the system down with it. Now, before we get into the actual tactics, let's rewind for a second, because the origin story here is just too good. Why do we even call them bugs? Well, back in the early days of computing, machines literally filled entire rooms and ran on these clunky physical hardware switches. And one day, a literal insect, an actual moth, flew into the machine, got stuck in a circuit, and crashed the whole system. The engineers had to go in and physically debug the machine. And ever since that day, any logical or technical mistake in software has been forever known as a bug. All right, let's get back to our crime scene and line up the usual suspects. You're basically going to be hunting down three main categories of bugs. First, syntax errors, those are your broken rules. Second, runtime errors, which cause your execution to crash. And third, logical errors, which just give you the wrong output entirely. Now, each of these error types leaves some very distinct fingerprints behind, so let's break them down. Suspect number one, the syntax error. Check out this line of code. We've got print, open parentheses, quotation mark, hello world, quotation mark, and that's it. Notice what's missing? The closing parentheses. Syntax errors happen when you basically break the grammatical rules of the programming language. Whether it's a missing semicolon, a typo, or weird indentation, you violated the structure. But the good news here? These are usually super easy to catch because your compiler acts like a strict grammar teacher and will immediately point out exactly where you messed up. Moving on to our second suspect, the runtime error. Now, this code might have perfect grammar, so it actually starts running just fine. But right in the middle of execution, something unexpected happens that just completely tanks the program. A classic example is trying to divide 10 by 0. I mean, that is mathematically impossible. Other examples might be trying to open a file that doesn't even exist. These are definitely trickier than syntax errors, mostly because they often only pop up under very specific conditions while the program is live. And that brings us to the absolute most dangerous suspect of all, the logical error. Look at the logic here. Total equals A minus B. The syntax? Flawless. The program won't crash. But what if you actually wanted to add those two numbers together? That's the scary part. The program runs perfectly in total silence with absolutely zero error messages, but it feeds you completely incorrect data. As the detective, you have to carefully step through your own logic to figure out exactly where your brain took a wrong turn. So this really brings us to the core of the whole investigation, that painful disparity between expectation and reality. We expect a nicely calculated number, but instead, our actual output is a catastrophic crash, like from that division by 0 runtime error we just talked about. The gap between what we want to happen and what actually happens, that is exactly where the magic of debugging takes place. Okay, so how do we systematically close that gap? Here are the 5 vital steps to solving literally any code mystery. First, identify your expected versus actual output. Second, reproduce the error. If you can make it crash consistently, you can study it. Third, locate the exact line causing a crash. Fourth, apply the fix. So for our division by 0 bug, that just means adding a simple if statement to check if the divisor is 0 before doing the math. And finally, step 5, test it again. Testing is absolutely mandatory, because sometimes fixing one bug accidentally spawns 2 more. Now it's time to open up our detective's toolkit. Our very first interrogation tactic is the oldest, simplest trick in the book, print debugging. By just dropping a quick print statement into your code, something like print current variable state, you are literally forcing the program to confess exactly what it's holding on to at that exact millisecond. Honestly, even the most elite developers still rely heavily on print debugging. It's fast, it's simple, and it shows you exactly how your data is flowing. But hey, when printing isn't enough, we move on to my personal favorite method. It sounds completely absurd, but it is highly effective. Rubber duck debugging. Yes, you are reading that right. You literally put a little rubber duck on your desk, and you verbally explain your code to it, line by single line, out loud. Why does this work? Because when you force yourself to vocalize your logic slowly to an inanimate object, your brain totally shifts gears. You stop glossing over your own assumptions, and suddenly those hidden logical flaws just jump out at you. Seriously, try it.
Now, when print statements and rubber ducks still aren't cutting it, it's time to bring out the heavy-duty detective gadgets. Depending on what language you're coding in, there are some incredibly powerful tools for this. Python folks, you've got PDB. JavaScript, Chrome DevTools is your best friend. Java developers swear by the debuggers built into Eclipse or IntelliJ. And for C and C++, GDB is the absolute gold standard. These tools let you essentially pause time inside your program using a breakpoint. Then you can literally step through your code line by line and watch your variables change in real time. It's a game changer.
But look, all these tools are totally useless without the right mindset. You've got to develop the master mindset. First off, actually read the error messages. Don't just panic and close them out. They literally tell you what and where the problem is. Second, write clean code. Third, test small chunks as you go rather than waiting until the very end. And fourth, and I literally cannot stress this enough, take short breaks. If you've been staring at a logical error for 2 hours, get up, walk away. Actually, scratch that. Run away from your desk for 10 minutes. Coming back with a fresh mind is usually when the mistake becomes glaringly obvious. To wrap up our explainer today, I just want to remind you, encountering bugs is not a sign of failure. It is simply the reality of writing complex instructions from a machine. Every single bug you track down, every mystery you solve, it builds your logical thinking, your patience, and your overall mastery. It's how you level up. So, I'll leave you with this final thought to ponder. What was the hardest bug you ever faced while coding, and what did it teach you? Keep practicing, stay curious, and happy investigating.
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to Future Break Coder, because many exciting coding and futuristic tech videos are coming soon.